Very good morning, children. My name is Anand Kumar Tiwari, and today we are going to discuss about a new topic that is there in NCERT chapter. I think that is chapter number 5, differentiation. And of that chapter, that is of differentiation, I have chosen to discuss and solve the numericals of second order derivative, which is also known as higher order derivative. Now, in the previous 3 sessions we discussed about relations and functions, its concepts and its numericals. This shift from chapter 1 to this differentiation, it is because of the fact that some of the children had difficulty, or they could not understand the methodology of second order derivative and found it little bit tricky. Not difficult, I am saying little bit tricky. So I thought that why shouldn't we adopt some new and interesting method which can fetch full marks to the students. We start with the second order derivative. In some of the cases, second order derivative is found to be quite easy, like the case if I take that y equals to say x to the power of 5 children. Now dy by dx, the first derivative which we have been, or you must have attempted in differentiation. So first derivative is found to be 5x to the power of 4. Now if I go for higher derivative, that means if I differentiate this derivative again, so I get 5 times d dx of x to the power of 4, which when differentiated we get 4x cube, that is 20x cube. So here when we proceed from first derivative to second derivative, which is in simplified form written this way, and if we differentiate further, then it is further, if I go for third order derivative, then we will write this y as d cube y upon dx cube, and then differentiate it further, so we get the higher order derivative. Higher order derivative we are calling it because of the fact that first, then second, then third, and then fourth, and so on. However, in our syllabus it is limited to fourth, maximum 4 order. So in higher order derivative, in some cases, as I mentioned in the beginning, it is found to be easy. So this was one of the cases. Take another case. If I take y equals to sine of x. Now if I go for first order derivative, it is found to be cos x, and if I differentiate it further, that means मैं निकालने जा रहा हूँ second order derivative. So cos x differentiation is found, or it is there as minus of sine x. And if I go for further, that means third order derivative, then it is found to be minus of cos x. So you may be noticing a fact that it is almost it is more or less same function we are getting every time. So you might be saying that what difficulty is arising here. It is in some cases, as I said, it is not as difficult, but in some cases second order derivative becomes slightly tricky. It requires more focus, more attention than first order or second order. That means when we go for higher order, we have to be more focused, more calculative, and then one differentiation or while differentiating, a chain rule has to be applied, cross multiplication has to be there, squaring has to be done. So these particular cases, going for squaring or cross multiplying, these cases give us a better method to make the sum very easy. So far it is okay. Now I go for slightly difficult one. So that is slightly difficult one I take from NCERT, which is having, which we have got, it is there, suppose example number 38, example number 38 we have got it. So that is d square y upon dx square. We have to determine, children, and the condition that is given us, y equals to x cube plus 10x. Now we are asked to find out second order derivative. It might be seeming to you very easy, and it is indeed very easy, because of the fact that it is not having any squares or roots or log or composite functions that we call as. So go for the first order derivative. We find dy by dx equals to 3x square, and 10x differentiation is sec square x. So first, it is first order derivative, that is y1, is easy. Children, do remember that dy by dx is also denoted by y1, and at some places you will find it is denoted by y dash, first order derivative. So it is clear that the y2 will differentiate second order, and y3 so on. Now we differentiate it further with respect to x, both the sides. So we get d square y upon dx square as 6x, and here we have to apply chain rule. So to apply chain rule, I will explain you this way. Right, this one is sec of sec x whole square, and assume or consider this as x. So x square differentiation, so x square differentiation is 2x, right, and this sec x we assumed as x, so it will be differentiated with the help of chain rule. So chain rule we apply whenever there is a composite function or the functions are slightly complicated type. So d by dx of sec x we will go for, and then we get 6x plus twice of sec x, and sec x differentiation we studied in class 11 and also studied in the initial parts of differentiation. So sec x differentiation is sec x into 10x, and then further we can write down twice of sec square x into 10x. So that is okay. Second order derivative is not as difficult as I had thought of, but it is good to have that at least we are not getting difficult sums so far. So it is all right. Now we proceed further for the next example, which is there in NCERT, that is example number 39. Example number 39, which is saying that if y equals to a sin x plus b cos x, then prove that, what to prove, d square y upon dx square plus y equals to 0. This we have to prove. So now we are inching towards slightly difficult level. and do not forget that we are concentrating on second order derivative, second or higher order derivative. This is the subtopic we have selected for today's video. So let us start the proof rather than writing. This is a proof for us. So now go for first order. So dy by dx, that means differentiating with respect to x, both the sides. Now a is a constant, so it will be there. Then d by dx of sin x, and likewise b is a constant, so it will be there, and d by dx of cos x. Then we go for, then d by dx of sin x is cos x, and d by dx of cos x is minus of sin x, so minus of b sin x we get here, children. So this is okay. First order derivative, that is y1, we have got it. Now we differentiate for again, that means y2. So d square y upon dx square, again dy dx of cos x minus of b, then d by dx of sin x. Now again the same thing, d by dx of cos x is minus of sin x. So here I will write down, so y2 equals to, we get minus of a sin x, and then dy dx of sin x is again cos x, so minus of b cos x, minus of b cos x, we get it. Now minus is common, so minus is common, and then the leftover part is written inside the bracket, is this. And now see the given part. The given part is this, a sin x plus b cos x, and here also it is written as a sin x plus b cos x. So we can replace this one by y, so we get y2 equals to minus y, or y2 plus y equals to 0. Some of the children, some may adopt a method that they get y1 and y2 separately, and instead of concentrating here and here y1 y2, what they simply do, they take out y2 and y1 or y2 value as per the requirement of the question, and substitute in the proof part, and then anyhow manage to cancel the terms with plus and minus and get 0. That is all right for fetching marks, but to develop confidence, to get good confidence in this topic, you should get the complete explanation and complete solution. So far I think this part is clear to you, and this was slightly tricky than the previous two examples. Now we go higher part, higher difficulty level, and there you will find out that some more interesting questions are there. So there it is, example number 41. This one I rate as one of the important questions. Example number 39, children. I rate this example as one of the examples of most expectation from the point of view of board. Then example number 40 is there. which I will write it down, but I would suggest that the children will try a little bit themselves, because as it is not going to be as difficult as the coming out ones. So y equals to, we have got y equals to, it is 3 times e raised to the power of 2x plus 2 times e raised to the power of 3x. 2 times e raised to the power of 3x, and then we need to prove that, what we need to prove, that d square y upon dx square minus 5 dy by dx plus 6y equals to 0. This has to be proved. So let us start the proof and then see how we get the proof part. So y1, that is first differentiation. So 3 times d dx of e to the power of 2x, and then here we have to be more than 2 times d dx of e to the power of 3x. Now this will be there, e to the power of 2x, and we do know that the derivative or differentiation of e to the power of x is e to the power of x. So we write down this one as it is, but it is not x. It is not x, so we have to go for chain rule. So d by dx of 2x, and likewise here also. So let us see that how
Stop.
we get it. Right now, d dx of we get what, 3x children here. Then simplify it further. So what we get, 3 times, and this will be as it is, and 2x differentiation, it will be 2 because x differentiation is 1. So it is reduced, this one is reduced to 2 and this one is reduced to 3. So 2 3s are, it becomes, okay, just point write down 2, and likewise here 2 times e raised to the power of 3x into 3. So 3 2s are, we are getting 6, and this is what we are finding, it is y1. As I said in the beginning, it is going to be slightly difficult. So far the previous cases we discussed, they had come out anyhow, but this is not going to come anyhow. We have to be more focused, more attentive. 3 to the 6 e to the power of 2x, and here again 6 e to the power of 3x. This we got as y1. Now we have to go for y2. Then while going for y2, we get 6 times d dx of e to the power of 2x, then again 6 times d dx of e to the power of 3x. Then just now we differentiated e to the power of 2x, so this I will write down directly, 2 times e to the power of 2x, and likewise here 6 times this will be equals to 3 times e to the power of 3x. Then this becomes 12 e to the power of 2x, and this becomes 18 e to the power of 3x. This is our y2. So y2 we have got it. We have got y1 also. Now we can go for slightly easy method. Substitute the value of y2 and y1 as well as of y, and then cancel out the common terms, and then you might get the resultant, that is 0. So this way, that is all right. Then because arranging this one in this form, it might take time, how it requires some logical aspect also. So that is all right. Now I move to the next one, which I rate as one of the most important questions, children. One of the most important. However, this one was important. This one was important, but now we are turning to most important one. So the most important one is now going to come, and I wish that you should score full marks and adopt right methodology. If you adopt right methodology, then you will easily fetch full marks. The question is that this is going to be example number 41. Y equals to, we are given sine inverse of x, and do not bother where x belongs to, whether it is in principal branch or anything. If it is something is not mentioned, then consider x in a principal branch. Then what we are supposed to prove is that, then prove that 1 minus x square times y2 minus x times y1, that is homogeneous expression I follow, equals to 0. This type of question where students find a little bit difficulty. So let us proceed by step. So we go for y1. So differentiation with respect to x. First differentiation, we get what? dy upon dx. And sine inverse x differentiation we have studied in the starting exercises of differentiation. So it is going to be 1 upon root over of 1 minus x square. Now this one I write down as y1, children. Now here it is got a square root. I go for cross multiplication first, and now your attention in more extent is required. Go for cross multiplication, you get root over 1 minus x square y1 equals to 1, I think, yes, it is 1. Cross multiply, we get this expression. Square root is here to make the second order derivative, or the expression that is required or that is asked to prove, we go for squaring. So squaring both the sides, and when we go for squaring we get 1 minus x square y1 square, and 1 square is obviously 1. However, the method you can adopt something else, can directly apply product rule and go for, but this I will tell you how it becomes easy. Now we have got one function here, we have got another function here, so it is indeed a product of two functions. This expression is a product of two functions, so we adopt product rule. So what we do, we write down 1 minus x square as it is d dx of y1 square, and now y1 square we keep as it is, and d dx of 1 minus x square, and other side also d dx of 1, differentiating both the sides again. So here we have to write down that we need to write down differentiating with respect to x again, because we have already differentiated once. Now what do we get? Let us see. It is 1 minus x square here. This is the important part, because by squaring I have made something easy, certain steps easy. but at the same time, children, it will be slightly tricky. It will require more attention. So y1 square differentiation is just like x square. So, or y square you can say. So y1 square differentiation is 2y1. Just understand and apply the chain rule. So 2y1 we got it, and then differentiating y1 again. Just understand it again. We consider y1 as x. Oh, not 2x, better to say y. So y square becomes 2y, and then y1 will be differentiated again. That means we have to apply for chain rule. If it is a case, means make sure if it is a case of any other variable except x, so it has to be differentiated with the help of chain rule. Now here it is y1 square, we will write down y1 square as it is and differentiate this one. So 1 minus x square, when differentiated we get minus 2x, and 1 differentiation is 0, children. Now you observe, or you must be observing that y1 is going to be common, as well as 2 is also going to be common. So take out the common terms and then write down the left one. But here ddx of y1, that means y1, when we differentiated y differentiated first becomes y1, y differentiated once becomes y1, and y1 differentiated again it becomes y2. So this one we can write down as y2. So we get what? y2, and this is already common, so y2 times this one. So we get 1 minus x square y2, and this is already common, so we are left with minus x, and 1 y1 will be there because we have taken 1 y1 equals to 0. Was the same asked? Was this the proof? Was this the proof or not? Let us see. 1 minus x square y2, it is there. Minus x y1, it is there, equals to 0. So the key point is that if you find a square root, then go for squaring, then the terms becomes easy, and the differentiation also becomes easy, and you get the desired result. However, the children go for adopting product rule here, and in between they get a little bit stuck and sometimes leave also, not always. I hope this was clear and very easy. And likewise, you will have a question of cos inverse x. You might have a question of cos inverse x, and then almost similar type of question, similar type of proof may be there. So this was one of the different method I adopted, and the same one is given in NCERT also as alternative method, children. So it is there. Now the other one which I will take as the important one, it is there, the question number 13, children. Question number 13 of exercise is there. The exercise is it is 5.7. So question number we take 13. Question number 13 is there that if y equals to 3 cos log x plus 4 sin log x, then prove that. Question is what? Y equals to 3 cos log x and 4 sin log x. You must be observing it is an example of composite functions, which is the part of chapter 1. So differentiation and integration both are linked to composite functions, or better to say first chapter, right? Now what we are asked to prove, that show that x square y2 plus x y1 plus y equals to 0. This we have to prove, children. Now by looking at the expression, you might be thinking that it is slightly difficult or tricky, or may go for 2 to 3 pages, but it's not like that. We will make it easier. So we start with the proof and differentiating with respect to x both sides, right? So what do we get? That dy by dx equals to, now this is 3 times cos log of x plus 4 times ddx of sine of log of x. Then what do we get? Now here it is the cos of log of x, so we assume this one is x, and since it is a case of composite function, so we have to go for chain rule. So we assume this one as x, so it becomes cos x, and cos x differentiation is minus sin x, so x will be written as log x, and chain rule will be applied over log x. जो x के प्लेस पर होगा उसमें चेन रूल लगेगा. आप नॉर्मली इसको एज्यूम कर लीजिएगा x cos x डिफरेंशिएशन इज माइनस साइन x मत रखिएगा, इट विल बी log x, एंड जिसको आपने x एज्यूम किया है उस पर चेन रूल लगेगा ही लगेगा. कीप इट इन माइंड. Likewise, once you are alert here, you will find this thing interesting. So 4, again assume this one as x, sin x differentiation is cos x. Cos x means cos of log of x, and then chain rule will be applied to over log x. So d by dx of log of x, children. Now simplify it further. So d by dx of log x is becomes 1 by x, and likewise here also will be 1 by x. So y1 we get as what? Minus, we write down minus 3 by x sine of log of x, minus 3 by x sine of log of x, and likewise the other term, it becomes 4 of x cos of log of x. You might have understood, I hope. Still I repeat it. This becomes 1 by x, so that 1 by x I have multiplied to 3, so that becomes 3 by x, and likewise here this became 1 by x multiplied to 4, so that's why it became 4 by x. Now go for cross multiplication of x, or multiply both sides by x. So multiplying both sides by x, we get x y1, and when we multiply x both the sides, so these x will get cancelled, and it is reduced to minus 3 sine log of x plus 4 cos log of x. This will be easier for us. Now since we have to go for second order derivative, again differentiation is required, so we write down differentiating with respect to x, again both the sides. So here ddx of x y1, and here previously we have already done, so straight away I will go for direct. It is going to be what? 3 sin log x, so it is going to be minus 3 cos log of x. As I told in the initial case, it is to be assumed as x, so it becomes minus 3 cos log of x, and log of x differentiation by chain rule, which we have already practiced, is 1 by x. And here also cos of this one, so cos differentiation is minus, so it becomes what? Minus 4 sin log of x upon x children. Some space, more space is required. I have to rough this question. Hope by this part you can get the desired result. Now here we apply product rule. So when we apply product rule, we get x ddx of y1, then y1 ddx of x equals to, or rather to write down, better try to, equals to, here this is the next step, and this one we take out x common and minus also common. See, minus will be common, x will also be common, and let us see over the leftover part. So we get minus 1 upon x here, and then we are left with 3 cos log of x plus 4 sin, I hope it is visible, 4 sin log of x, and I have rubbed it, but